All right, everybody, this is Mr. Ainsworth, and we're going to get into yet another review 3 on linear functions, and this covers all of Chapter 5 in your textbook here, as well as Section 6.5. Okay, and let's start off with, how about point-slope form and slope-intercept form, finding the linear function. Okay, so given a set of ordered pairs, which is called a linear relation here, all right, the goal is to find the linear function itself, which describes how to find y when you know x. Like, what do you do to 3 to get to 10? What do you do to 6 to get to 16? That's the linear function here. So we're going to assume that it's linear here. And because of that, we need to find the changes in y and the changes in x to find the slope. Because we know that the slope, which is defined to be m here for a variable for monter, okay, it's a French word meaning to climb. Just giving a little history here. That's why we use m for slope instead of s. Okay, so m is the change in y, delta y, divided by the change in x, delta x. All right, to find the change, you find the difference between two y values. So the difference between 10 and 16 is 6, right? 10 plus 6 is 16. So this is a positive 6 change, right? 10 plus 6 is 16. 16 plus 6 more is 22, and 22 plus 6 is 28. Notice there's a constant change. All right, so we call that delta y, or the change in y. And notice here that the change in x values, called delta x, is 3, right? 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. And notice that delta x is equal to 3 here. Well, this delta x, which is right here, is 3. So what we do is we take the change in y divided by, all right, the change in x. This fraction means division, right? So 6 divided by 3. Well, what's 6 divided by 3? Well, it's 2. All right, so the slope between the points here, if you were to graph them, is 2. All right, that'd be up 1, right 2. All right, now the whole goal is to find the linear function. That's what it says here. Find the linear function. Two different ways. There's two different ways to do that. You can use slope-intercept form, or you can use point-slope form. Slope-intercept form, you find the y-intercept after the slope. So you pick a point. It doesn't matter what point you pick. So let's just pick 3, 10. All right, 3, 10. All right, x is 3 and y is 10, and substitute it in. So 10 is equal to the slope, which is 2, times 3. There you go. Plus some y-intercept. We don't know what that is. The goal is to find it, right? Because we don't have the y-intercept in the table. All right. If you look at it, 0 comma something is not given in the table. Now we could use the change in x and the change in y to work backwards to get to that. We could subtract 3 here. Okay. Subtract 3, go backwards. All right, and subtract 6 here and go backwards. Not there. I'm sorry. There we go. Subtract 6 from 10 and go backwards. We could do that, and we'll do that here in a minute. But let's figure out b algebraically here. So 10 is equal to 6 plus something, right? 6 plus what is 10? Well, it's 4, right? b has to be 4. So I know that the function is y is equal to 2x. Why 2x? Well, the slope is 2, right? And m is 2. So you have 2x plus b, which is 4. So we know the function now. Now we could have done that by working backwards. If you subtract 3, you get 0. 3 minus 3 is 0 here. And 10 minus 6. Let's see, if you add in 6 to go forwards, to go backwards, you subtract 6, right? So you go minus 6 here. 10 minus 6 is 4. And right there is the y-intercept. 0 comma something is always the y-intercept. So I could have got b that way using the table and the changes right here. All right, a lot of you guys know how to do that. So that's one way. Or you can do it algebraically. That's how you do it using slope-intercept form. Now using point-slope form, what you do is you pick a point in the table, any point you want, and you pick the slope. Well, we already know the slope is 2. So I'm going to use a 2 here. So I'm going to write down m equals 2. And I'm going to pick one of these points. And I'm going to pick a different point because it doesn't matter. I'm going to pick a different point just to illustrate the fact that it doesn't matter which point you pick. So I'm going to use 6, 16 just to show you that it doesn't matter. Because all these points are on the line, right? So it shouldn't matter what point I pick to determine the linear function. Okay, so if I pick 6, 16, I know that x1 is 6 and y1 is 16. So I have y minus 16 is equal to 2. Remember, the slope's 2. I calculated that earlier. Times x minus the x value of 6. Well, distributing through, I have y minus 16 equals 2x minus 12. You got to multiply twice, as you guys already know. If I add the opposite here and I isolate the y variable, and I get y is equal to 2x plus 4, because 16 minus 12 is 4. And notice that these are the same, right? And that obviously better be the case, because there will only be one linear function describing the same set of ordered pairs. All right, so whether you use slope-intercept form or point-slope form, it doesn't matter. Okay? Regardless of the two techniques, you have to find the slope first. Okay? It doesn't matter which technique you use. All right, and then you check it. Okay, so let's take this point right here. So x is 12, right? So 2 times 12 is 24, plus 4 more gives you 28. Oh my God, it works. If you check 9, 22, that works too. So 9 times 2 is 18, plus 4 more. Well, guess what? That's 22. So what you do is you check another order pair to make sure it works. Make sure your arithmetic is good. Okay, on this one here, we want to evaluate the function algebraically and also graphically. We're going to find f(3). All right, let me write that down. We're going to find, all right, f of 3. When x is 3, what's y value? What is this value? This is a y value. Well, to do it graphically, you graph the function, and good thing for us is that it's in slope-intercept form. So notice that the slope here is 4/3, and the y-intercept, well, the y-intercept is -4. So I'm going to start at -4 on the y-axis. Why? Because that's a y-intercept, right? Right here. And then on the slope, I got 4/3, so I got to go up 4, right 3. So 1, 2, 3, 4, 1, 2, 3 to the right. Plot a point. Up 4, 1, 2, 3, 4, 1, 2, 3 to the right. All right, and then you graph the linear function. So let's do that. Okay, so I use the y-intercept. All right, I go up 4, right 3, and I plot another point, and I draw the line. And then I ask myself, where is there a point on the graph? Where is there a point on the line here where the x-coordinate is 3? And it should be obvious. All right, let me plot it. It's right here. All right, there's x equals 3. Well, what is that point? Well, it's 3, 0. So the y-coordinate is 0 in this case. 3, 0 is on the graph. So I know the y-coordinate 0. So the f of 3 equals 0. That's how you do it graphically. Just find the point where x equals 3 on the line and look at the y value. To look at the y value, you just look at the y-axis, and it's y equals 0. Now, using the function is a little bit different. Okay, you take the function, which is 4/3 x, all right, minus 4. To find f of 3, what you do is you take the x value, all right, and you substitute it in, all right, algebraically. So you got to take 4/3 times 3 and then minus 4. And you got to be good at arithmetic, right? All right, so what is 4 times 3? It's 12. 12 divided by 3 is 4. 4 minus 4 is 0. So we say that f of 3 equals 0. And notice that it's the same result, okay? Notice that this number here matches this number here. It's the same. And it should be. If you don't get the same algebraic result as you do on the function or on the graph, all right, this is called a graph, then you know you made a mistake, okay? They should be the same. Okay, I don't know if you noticed this, but there's a theme right now in my review here. I'm finding the linear function 2 different ways, okay, and they should be the same. I'm finding the function value, the y value, 2 different ways, first graphically and then algebraically. And now I'm going to graph the function in standard form 2 different ways. All right, now this is standard form. This is ax plus by equals c. This is called standard form. There's 2 ways to do it. When it's not specified what way you to graph it, then it's obviously up to you, but I'm going to do it 2 different ways. The first method is called the intercept method. Why do you say intercept method? Well, I said finding the x and y intercepts, right? So it's called the intercept method. Okay, and to do that, it's a method of zeros. Okay, so you substitute 0 for x and solve for y. Okay, that's called the y-intercept. And then you substitute y in for 0, or 0 in for y, and you find the x-intercept. Okay, it's that simple. All right, so let's do that. Let's take your function, x minus 3y equals 6. That's what I give you up here. And let's put 0 in for x first. All right, so 0 minus 3y equals 6. That gives me negative 3y equals 6. Whoops, 6 here. I got to write it correctly here. All right, and just look at it. Negative 3 times negative 2 equals 6. So y equals negative 2. Negative 3 times negative 2 is 6. So y is equal to negative 2. So I just found my y-intercept. So you plot it. So you plot on the y-axis, y equals negative 2. The vertical axis is the y-axis. So this is your y-intercept here. All right. Obviously, the y value is a y-intercept, not an x-intercept. Just use your common sense right there. And then when you figure out the x-intercept, well, you got to substitute y 0 in for y. Right there in for y. Okay, so here we go. So x equals 3 times 0 equals 6. Well, that gets wiped out, and you get x equals 6. So this is called your x-intercept because you got an x value, right? Use your common sense. So you plot 6 comma 0, which is right 6, and that's a little bit off the graph. So let's approximate. All right, just extend the axis here, no big deal. And you're at 6 here. So just approximate right there. And then draw your line at that point. Believe it or not, it's that simple. There you go. So after you plot the y-intercept up here, x-intercept right here, and you plot the y-intercept here, you draw your line because 2 points determine a line. I mean, it's been that way ever since grade school. And you grab a ruler, right? And they ask you to draw a line. Well, plot one point, plot another point, use your ruler, line them up, and draw a line. 2 points determine a line. Okay. The second method is isolating y and getting slope-intercept form, which is y equals mx plus b, which means you got to isolate the y variable here. Okay, and obviously in the function it's not isolated. So let's write down the function x minus 3y equals 6. Your whole goal is to isolate this variable y, so let me highlight it. So we always add the opposite first of the x term. So x is positive x, so either subtract x or add a negative x, however you want to think about it. It's the same thing. All right, x minus x is 0. They cancel out to 0 here. Anything minus itself is 0. And you bring down the result, okay? Let's see, so you have negative 3y is equal to negative x plus 6. You add the opposite to both sides. So negative x plus 6. I wrote it at this way because you want to write it in slope-intercept form. Notice the mx plus b form. Divide everything but through by negative 3. Everything, all three terms. And you get y is equal to positive 1/3 x. Notice there's a 1 up here. Negative divided by negative is a positive, so they cancel out. 6 divided by negative 3 is negative 2. So I know the slope and I know the y-intercept. All right, so you plot the y-intercept first, which is right here. Notice that I've already plotted it. So this right here, this method here, verifies what I did earlier, because if you start at negative 2 on the y-axis and you go up 1, right 3, you go up 1, right 3, which is right here, up 1, and right 3, it verifies it. So there's your slope. Up 1, right 3, up 1, right 3, and you end up at 6. All right, so you can use your slope right here that I'm highlighting right here. So use the slope to verify the previous intercepts. Okay, so one method verifies the other. So if I ask you this on the test, no big deal. You try one method and you verify with the other one, and then you know you're right. Okay, now if I say graph by plotting at least 3 points, all right, then you got to pick an appropriate domain. Now you can pick any domain you want. Okay, so the domain for linear functions is all reals. Domain is all real numbers. However, to make arithmetic easy, you might want to take a look at the denominator here, which is 2, and down here is 5, and pick multiples of the denominator. So I would say picking multiples of 2 would be a whole lot easier, especially for the arithmetic. If you don't, then you're going to deal with fractions. All right, so pick negative 2, 0, and positive 2. Watch what happens. So you're going to take 1/2, all right, times x value minus 1. So times -2 minus 1. All right, let's do the arithmetic. What's 1/2 of -2? Well, it's -1. -1 minus 1 is -2. What's 1/2 times 0 minus 1? Well, anything times 0 is 0, right? And 0 minus 1 is -1. So what's 1/2 times 2 minus 1? Well, 1/2 of 2 is 1. 1 minus 1 is 0. So once you get 3 points, you plot them. So let's do that. So -2 comma -2. So left 2 down 2. 0 comma 1. No, excuse me, 0 comma -1 is down 1. All right, and then 2 comma 0 is right here. And then you can see that the slope is up 1 right too, which should be the case because I can see the slope right here. All right, so plotting by points gives you the same thing as using the slope and the y-intercept. Okay, and then after that, what you do is you get your straight edge out and you draw your line. All right, there we go. Once again, here's the slope, up 1 right too, so you can verify it that way. Notice the y-intercept of -1. Okay, so if we knew about the y-intercept right here, which we do obviously, all right, we can verify that our points are correct because we understand slope and y-intercept as well. So what you do is you put all your skills together. You put the slope and the y-intercept skills in with plotting points, and they should all back each other up. It should verify one another. If one thing doesn't verify the other, then you know you made an algebraic mistake. Okay. Now, number 5, you probably want to pick multiples of 5, all right, because the denominator is 5, right? Because you know you're going to have to take 3/5 of it, which means you're going to have to divide it by 5. So I would pick multiples of 5. -5, 0, and 5. Always pick a little bit of negative, a little bit of positive, and neutral, which is 0. Always pick 0. Okay, so here we go. 3/5 times -5 minus 3. All right, 3/5 times x minus 3. Well, you can multiply first, you can divide first. If you divide first, it looks like this. All right, -5 divided by 5 is -1, times 3 is -3. -3 minus -3 is -6. And then dealing with 0 is easy. All right, 3/5 times 0 is just 0, minus 3 is -3. And then 3/5 times 5 minus 3, well, let me see. 3/5 times 5, 5 divided by 5 is 1, 1 times 3 is 3, minus 3 is 0. So here we go. Left 5 down 6, which is here. 0 comma -3 is here, and 5 comma 0 is right 5. So you plot those points. There we go. And you know you're right because the slope's 3/5 and the y-intercept's -3 here. And you can see that you go up 3, right 5, all right, at the y-intercept of -3. Okay, and so you know you're right because the slope's correct, 3/5, and the y-intercept is correct. So you know these points are correct. So you know the points are correct by using your basics on the slope and the y-intercept. Okay, that's called putting your skills together. Okay. All right. Now here we go. Now find the linear function, and we've done this before in the first question here. Find the linear function using what's called point-slope form. Okay, we've already done this before, so it should be straightforward here. We got to find the slope first, as we always do. Always find the slope first because you need it no matter what technique you have. And to do that, well, I would suggest that you subtract up, right? Because the slope is the difference of the y values, delta y, divided by delta x, all right? So the slope is always the change in y, all right? The second y value, subtract the first. That's why I always say subtract up. Okay, so here we go. So the slope is 10 minus 4 divided by 0 minus 3. I always start with the y values. That's 10 minus 4 divided by 0 minus 3. Subtracting up on both, okay? You get 6 divided by -3, and so obviously the slope is -2. 6 divided by -3 is -2. And then you get to pick one of these points. All right. I would pick always the easiest one. Okay, so I would pick 0, comma 10 because you're dealing with 0 here. All right. So write down easier. Well, not easier. Don't write that down. I would always pick the easiest one, the one involving zeros, right? So you choose. It doesn't matter what point you pick, you choose. I'm going to pick this one. X1 is 0, Y1 is 10. So here we go. Y minus the 10 is equal to, the slope, excuse me, negative 2. There's your slope right here, times x minus the x coordinate, which is 0. So simplify, you get y minus 10 is equal to negative 2 times x. X minus 0 is just x. Add the 10, and you're done. Y is equal to negative 2x plus 10. And that is it, my friends. That's how easy it is. All right, find a linear function using point-slope form. Find the slope first, step 1. Step 2, find the equation itself. I like that more than slope-intercept form because it's just, there's no thinking involved, really. I mean, you just find the slope, plug it in, and the point you pick is up to you, and then the equation results. I mean, it's just it's a piece of cake. All right. Next one here, you got to go from slope-intercept form, which is y equals mx plus b, into standard form, which is, well, you got ax plus by equals c. That means variables on one side, all right? All right, so the thing here is you got to clear the fractions first. All right, so whatever the denominator is, multiply by it. Okay, so multiply both sides by 7. All right, so here we go. You got on the left side, you get 7 times y. On the right side, you got distribute. Now, let's do a little side work. For those of you who are not good with arithmetic, here we go. 3 sevenths x times 7. So 3 sevenths x times 7. Well, if you multiply by the denominator here, look what happens. 7 divided by 7 is 1. All right, 3 times x times 1 is just 3x. That's why we call it clearing the fractions, because when you multiply by the denominator here, guys, all right, there are no fractions resulting, all right? That's what clearing the fractions means. So 3 sevenths x times 7 is 3x. 7 times 2 is 14, so you get minus 14. All right, slope standard form is all about getting the variables on one side, so you got to subtract 3x here. When I say subtract, I'm talking about adding the opposite here. So the opposite of 3x is negative 3x. So add the opposite on both sides and then write the result. Negative 3x plus 7y. It's positive, right? I said add the opposite to both sides. Notice the plus sign right there. Add the opposite to both sides. And these cancel and you get negative 14. Okay? If you don't want to take the opposite of everything, you get 3x, all right, minus 7y equals positive 14. All right, so if you saw this in the back of the book, this is the same. All right, if you take the opposite of all three terms. But you're good here. All right, next one, number 8. We're going to graph each line, okay, and label. We're going to label each line. Okay, so here we go. So x equals 2. Now, in x equals 2, you want 2 points where x is 2. So how about 2 comma 1 and 2 comma 5? All right, let's graph these bad boys. So 2 comma 1, write 2 up 1. All right, write 2 up 5, which is right here. And so this equation right here, this is x equals 2. See, this is what I mean by labeling. I said label each line on the number line, or on the coordinate plane. When you have more than one line, we have 1, 2, 3, 4, 5, 6 lines on one plane. You better label so that I know that you know what you're doing. Okay, y equals negative 2. Okay, so y equals negative 2. So y equals negative 2. Well, once you plot 2 points where y equals negative 2. So how about 1, negative 2? How about 0, negative 2? So let's plot these bad boys. So 1, negative 2 would be 1 right down 2. All right, 0, negative 2 would just be down 2. And notice that we've got this line here. So this is y equals negative 2. Okay, so it's equation B here. All right, this one here, and see, the slope's 2/3 and the y-intercept's 2, negative 2. So we're going to start here at negative 2. All right, we're going to go up to right 3. So up to right 3, up to right 3, and graph a line. Okay, and label, right? Y equals positive 2/3 x minus 2. All right, label so that I know that you know what's going on. X equals -1. Well, here I need 2 points again, where x is -1. So -1 comma 0 and -1 comma 2. So let's plot. So plot -1 comma 0, plot -2. Excuse me, I didn't write that correctly here. Let's start over here. So here we go. So -1 comma 0 and -1 comma 2. That's what I meant to say. So -1 comma 0 is here. -1, -2 is here. And notice I'm going to graph the vertical line through -1 on the x-axis. Okay, because that's what x equals -1 equals. Okay, there we go. It's vertical line through -1. Okay, equation B. All right, this one is y equals 1x plus 3. So slope's 1, y-intercept's 3. So when you have a slope of 1, that's 1 over 1. That means up 1, right 1 from 3. So you start here at 3, and you go up 1, right 1, up 1, right 1, up 1, right 1. Reverse it, down 1, left 1, down 1, left 1. So you can just plot. You're going to see the line form. Okay, so there you go. So that one there's, all right, there's y equals x plus 3. And then the last one here, look at that, the slope's -1, which is -1 over 1. And if you put a plus 0 there, there's your b value. So b is 0 here, so you're starting at the origin. You go down 1, left, right 1, down 1, right 1, and you start graphing your line. If you want to reverse the slope, go up 1, left 1. Just keep graphing that line there using the slope and graph it from there. So that line right there is y equals negative x. So notice how I labeled each line so that I know that you know what's going on. There's no ambiguity right there. All right, if you don't do that, don't plan on getting in full credit, okay? You got to be specific, label your results. Make sure you let me know that you know what you're doing. Okay, on this one here, number 9, are the graphs parallel? Look at this, parallel. Are they perpendicular? Okay, or are they neither? Explain by analyzing the slopes of the line. Remember that parallel lines have equal slopes. Okay, look at this. Parallel lines have equal slopes. I just gave you the key concepts right there. And perpendicular lines have opposite reciprocal slopes. So there's no ambiguity here. So to do that, you have to solve, all right, for y and get into slope-intercept form. Y equals mx plus b, so you can identify the slope. So on the first one here, you divide by 2, and it's pretty obvious. -3 halves plus 2. -3 halves x plus, -3 halves x plus 2, that is. So the slope is -3 halves. Here, we're going to have to do a little bit more work. We're going to have to add the 2x. So you get 3y is equal to 2x minus 20. Divide by 3 on everything, that is. And you get y equals 2/3 x. All right, minus 20/3. Who cares what that is? The slope's 2/3. Now, if you notice here, this right here, I didn't write that correctly. It should be -3 halves. So let me fix that. When you look at it here, these right here, these are opposite reciprocals. Opposite reciprocals, and that tells me they're perpendicular. Perpendicular. Okay. All right, you can use the symbol here. Perpendicular means is the upside down capital T. So the slopes are opposite reciprocals. Boom, it's easy. One's negative, one's positive. They're reciprocals, which means they're inverted. All right, they're perpendicular lines. All right. How about the other two? Well, I don't know. You got to solve for y and look at the slope. All right, so let's subtract x here and let's do a little math here. All right, so we get -3y is equal to -7x plus 14. Divided by -3 on everything. Y is equal to 7/3 x minus 14 thirds. Who cares what that is? All right, and then on this one here, just add the fraction 7 thirds x on both sides, and you're done. This one's fairly straightforward, and you get y is equal to 7 thirds x plus 5. Well, here the slope's 7 thirds, and over here the slope's 7 thirds. So it's pretty obvious that the slopes are equal. So write that down. Slopes are equal. All right, draw an arrow, which means implies. All right, parallel lines, right? I mean, use your common sense. If the only way for two lines to be parallel is if they slope in the same direction, okay? I mean, just go back with your basic common sense of parallel lines and what it means. All right, number 10, 11. Going to, back to what I just said, okay? Parallel lines have the same slope. So what you do is you identify the key words. So if we're trying to find the equation line parallel to this one here, okay, we're going to use the same slope. Okay, m equals 2. And now I'm going to use point sub form, which means that the point I'm going to be using is 4, 0. So I write down point sub form and then go for it, which is something I've done multiple times previously in this review. Point sub form was asked for in the beginning because it comes out in these problems here. So we want to put your slope in, and you want to put your point in. So you're going to have y minus 0 because the y coordinate up here is 0. Just look at it. Okay, y1 is 0. And equals 2 here times x minus the x coordinate. If you look closely, the x coordinate is 4. All right, so you subtract 4. Then you just solve for y. So y minus 0 is just y. Distributing the 2, you get 2x minus 8, and you're done. It's that simple. Now, if you're going to graph them, it would look like this. You graph the original equation. The y-intercept's 1, the slope's 2. So you go up 2, right 1. Reverse it, down 2, left 1. Draw the line. So this is the original line. All right. Now, here the slope's 2, and here's the y-intercept is -8. So you go down -8, so -5, -6, -7, -8. There's -8 right here. If you're going to, let me just extend the y-axis here just for funsies here. Okay, and then down here is -8, and then you go up 2, right 1, 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 and you'll see if you graph this line, okay, right here, that wasn't correct. Okay, there we go. All right, they're parallel, all right, but down through -8. So you want it, and it obviously goes through 4, 0 here. So it satisfies the directions. I went through 4, 0 because I went up 2, right 1, and hit 4, 0. So they're parallel and offset, and it goes through 4, 0. So if you graph to check, you know that you're doing well because the graph verifies your algebra. Okay, on this one here, you want perpendicular lines. So that means that the slopes are opposite reciprocals. Okay, so let's do that. Let's take a look at the slope. So the slope is 1/3, right? So we're not going to use 1/3, no. All right, we're going to use the opposite reciprocal, which means we're going to use m equals -3. So you start with the point sub form, and you substitute everything in. So let's go for it. x1 is 2, y1 is 1. So you're going to have y minus 1 is equal to -3, right, times x minus the 2. Distributing through, what do you get? Well, you get -3x plus 6. All right, add the 1. Got to solve for the unknown. And you get y is equal to -3x plus 7. And then you graph to check. Graph to check. All right, so let's do that. Okay, so here we're going to graph this one. So here the y-intercept is -1. So start there. Slope is 1/3, so go up 1, right 3. Up 1, right 3. Reverse it. Left 1, down 1, left 3, excuse me. All right, and you graph the line. So let's do that. Okay, there we go. All right, the other one right here, the slope's -3 and the y-intercept 7. So you go up at 7. So 5, 6, 7 up here. Okay, approximating obviously 5, 6, 7. All right, -3, slope's -3. That's -3 over 1, so it's down 3, right 1. So down 3, 1, 2, 3, right 1. Down 1, 2, 3, right 1. Down 1, 2, 3, right 1. All right, graph that line, and let's see if it's perpendicular. All right, right there. All right, and just go ahead and take an index card, and you could check to see if that's a 90-degree angle right there. All right, perpendicular lines form 90-degree angles between them. Okay, and so it's got to look right. If they're parallel, they better look parallel. If they're perpendicular, they better look perpendicular. All right, and now we're getting into section 6.5. All right, section 6.5 in our textbook. Okay, on inequalities. So if you want to pull out your notes, here we go. All right, we're going to test -3 or +3 comma 2, x is 3 and y is -2 here in the equation. Determine whether it is a solution or not. All right, so here we go. Let's substitute it in. So I'm going to substitute negative into y, and I check, is 3 times 3 plus 1, is -2 less than or equal to 3 times 3 plus 1? I don't know. So let's simplify. So -2 is less than or equal to 9 plus 1. So is -2 less than or equal to 10? And that's going to be true, right? A negative is less than or equal to positive. More importantly, though, what does that mean? Well, it means that our test point here, 3 comma -2, is a solution. All right? And you have to put that. Don't put whether it's true or false. Tell me whether it's a solution or not. That's what I want to know. Okay? On the next one, 3 times 3 minus 4 times the y value of -2, is that greater than 5? I don't know. Let's check it out. 9 minus, no, plus, there's a double negative here. A negative times a negative is a positive, so let's put plus 8 here. Is that greater than 5? Well, let's check out. Is 17 greater than 5? Yes, it is. Okay, so what does that mean? It means that 3 comma -2 is a solution once more. All right, how about this one? Well, let's substitute it in. So is -2 equal to 4 times 3, all right, minus 14? I don't know. Let's figure it out. So is -2 equal to 12 minus 14? Well, if you simplify it, the right side, 12 minus 14 is -2, and it is. So, well, since that's true, what does that mean? Well, it means that 3 comma -2 is a solution one more time. Okay, so it just so happens that it's a solution to all of these. It's not always a solution, it just so happens to be coincidental this time. All right, you just substitute in the point and use your common sense. It's really that simple. Okay, now solutions to inequalities lie off the boundary line. So you got to be careful here. The boundary line of this one here, this is y less than -3/5 x plus 3. The boundary line is y equals -3/5 x plus 3. So what we want to do is here identify the slope, identify the y-intercept here, and then graph the boundary line first. So identify the slope, which is 3/5, identify the y-intercept, which is 3. All right, and then graph the boundary line. And just so you know, all right, you can predict, okay, this is less than, so this is going to be a dotted boundary line, which means, all right, the solutions are not on the line, not on the boundary line, that is, okay? And it's also going to be below. Solutions are below. Solutions are below. So what you want to do is you want to graph your boundary line. So let's start at 3 here. We're going to go down 3, right at 5. So down 3, right at 5. All right, draw your boundary line. So I'm going to draw it. However, you got to be careful here because it's dotted. So grab your eraser here. All right, make that dotted. All right, and then represent the solution region below the boundary line. This is called the solution region. All the solutions to the inequality lie below that boundary line, down here. Okay, not above, but below. Okay, now just to prove my point here, I'm going to pick a point above the line here. I'm going to pick this point, 3, 3. All right, I'm going to test it. 3, 3. X is 3 and y is 3. So here we go. I'm going to substitute. Actually, I'm going to make an easier one to pick. I'm going to pick 5, 5, which is right here. I'm going to prove to you that the points are not above the boundary line. Okay, so 5, 5. I picked 5, 5 because my denominator is 5. It'd be easier for you guys to understand. So testing 5, 5. X is 5, y is 5. So put 5 in the original here. Always test it in the original inequality. So is 5 less than 3/5 times 5, all right, plus 3? I don't know. Let's check it out. All right, simplify to get 3. Excuse me, I didn't say that correctly. Come on. 5 divided by 5 is 1. 1 times 3 is 3. 3 plus 3 is 6. So I get 5 is less than 6. All right, which is true. Ooh. What's going on here? Oh, it's negative. Oh, I knew I had a problem here. Negative 5. So a negative 3. So there's negative here. That's be negative 3. So I made a mistake right here. Negative 1 times negative 3 is negative 3 plus 3 is 0. 5 is not less than 0, so it's false. I knew I had a problem there because what I said had to make sense. All right, this is false, which means that 5, 5 is not a solution. All right, and it better not be. All right, because the solutions are below the line, not above the line. So write down not a solution up here. All right, I just use 5, 5 to verify the fact that it's not above, but it's below. Why? Because it's less than, not greater than. Okay? All right, I'll be right back. Okay, and let's continue here and finish this review on linear functions and linear inequalities here. Number 14 here we have a inequality in standard form, and there's two different ways you can do this. You can do the intercept method, or you can isolate y. For the purposes of video, I'm going to isolate y and get it into slope-intercept form. Okay, so we need to take a look at here and how to isolate y. So the very first thing I'm going to do is I'm going to add the opposite of x to both sides. Okay, opposite of x is negative x. So I take these and I get negative 3y is less than, okay, look at the inequality here, less than, all right, negative x plus 3. I'm going to divide the inequality, divide all terms by negative 3. Be careful though when you do this, you have to switch the inequality from less than to greater than. Okay, so I'm going to write a little note in red right here. So switch the inequality when dividing by negative. Okay, they're called inequalities. So switch the inequality when dividing by, all right, dividing by a negative number. So this always applies to multiplication or division. You always want to switch the inequality, all right, when you're dividing by a negative number. So I'm going to highlight that. So I switched it from less than to greater than. As soon as you do it, you switch it, all right? Now, negative x divided by negative 3 is positive 1/3. So I'm going to pull out the slope so you can see that. All right, these cancel. Look right here. Negative divided by negative is a positive. All right, x divided by 3 is 1/3 x. And 3 divided by negative 3, well, that's negative 1. So I'm going to write down negative 1 here, or minus 1. So I see the slope here is positive 1/3, which means up 1, right 3. And I know the y-intercept, b, is negative 1, or 0, negative 1. This is called a y-intercept. Now, since we're in slope-intercept form, I look here, okay? So I look at the greater than symbol. I know that the boundary line's dotted, which means the solutions are off a line. So a dotted boundary line, and I know that the solutions lie above. All right. If you go back and look at your lesson section 6.5, you can see all of this, okay? So section 6.5, greater than, dotted boundary line, solutions are above. If it was less than, I would say dotted and below. If it was greater than equal to, I'd say solid and above, okay? So what you want to do is you want to start at the y-intercept of -1, and you want to use your slope of 1/3, so go up 1, right 3, up 1, right 3, reverse it, go down 1, left 3, down 1, left 3. So you get a good boundary line right there. Always repeat the slope and plot many points. Okay, use your eraser and make it dotted. So I always draw the line, and then after that, looking at the inequality here, just make it a dotted boundary line because the solutions are not on the line there. There's your boundary line right there. And then looking at the greater than symbol, I know the solutions are above. All right, the solutions are above. Now, when in doubt, what you do is you test the origin, which is right here, 0, 0. You test it in the original inequality. So that's what I'm going to do in front of you here to show you that the solutions are above. Notice the origin's above. Okay, so if you substitute zeros in for x and y, you get 0 minus 3 times 0 is less than 3. Okay, and this is obviously true because 0 minus 0 is less than 3. This is a true statement, and because of that, this right here is a solution. Okay, whoa, what's happened here? Okay, that was kind of trippy. All right, so because 0, 0 is a solution here, that proves my point that the solutions are above the boundary line because 0, 0 is above the boundary line. Okay, so there you go. All right, and so be careful. Make sure you have the dotted boundary line here. The solutions are not on the line. Solutions are not, okay, on the boundary line. That's what the dotted line means. Okay, so keep that in mind. And the solutions are above. All these points are. All of these points. We call that the solution region. Okay, or the solution set, however you want to say it, but it's called the solution region or the solution set. All the points above the boundary line are solutions to the inequality, not below. You can pick any point below here and they're not below. Okay, they will not satisfy the inequality. Okay, now let's take a look at the last two here. So y equals -1. Well, this is a line. All right, we need to pick two order pairs where the y coordinate is -1. So how about -2, -1? How about 3, -1? Notice that y is -1, x can vary. Okay, x can vary. That means be any number you want. So you plot these 2 points, go left 2, down 1, so left 2, down 1, and go right 3, down 1, so right 3, down 1, and you plot your line. Okay, and notice that y equals -1 is a horizontal line. Okay, so when in doubt, if you don't remember the form of horizontal lines, okay, horizontal lines are always y equals k, or k is some constant here. All right, then you plot 2 points and 2 points to determine a line. Okay, it's that easy. Now this one here, x is greater than -3, so your boundary line is x equals -3. So you want to pick 2 points where x is -3. So how about -3 comma 1? How about -3 comma, I don't know, -3? So you pick any 2 y values you want, but make sure that the x is always -3. All right, notice that. So you plot the points. So you go left 3, up 1. So you go left 3, up 1. You go left 3, down 3, and that's down here. All right, and notice it's a vertical line passing through -3 on the x-axis. This is x equals -3. But notice here that it's greater than. Okay, so it's dotted. We have a dotted boundary line. So get your eraser out and make it dotted. Okay. We want to graph all coordinate points on the graph, okay? All points that are where x is greater than -3. And if you look at the x-axis here, and I'm talking about this x-axis, this horizontal one here, the numbers that are greater than -3 are -2, -1, 0, 1, 2, 3, 4, and so on. All of these numbers are greater than -3. So you just have to use your common sense here. Where are the values on the x-axis that are greater than -3? They're to the right. All right, so what you want to do is graph all coordinate points, okay, all coordinate pairs, which have an x coordinate. Who cares what the y coordinate is? But it has an x coordinate that's greater than -3, and they lie to the right of this vertical line. Okay, if you pick this point over here, like this point, this has an x coordinate -4. Just look at it. This is -4, 1. -4, 1. Well, that doesn't have an x value greater than -3, so you wouldn't graph to the left, you'd graph to the right. Okay, this is not a solution. Not a solution. Okay, so only points to the right. So notice that this is an inequality here. We have a solution region. Let me write that down again. This is a solution region or a solution set. These represents all the points, the infinite set of points that satisfy this inequality. Notice that it's a greater than symbol, not an equal to sign. Over here it's an equal sign, it's a line. All right, inequalities are shaded regions or solution regions, and then equals, when you have an equation, you have a line. There's a huge difference here, and know the difference between the two. Okay, now there was a lot done in here, so keep that in mind. If this is a video too, by the way, and so remember that you can always pause, play, rewind, and use the video to your advantage. Okay, this is an overview of all chapter 5 and section 6.5 in your textbook here in Algebra 1. Okay, and over what's called linear functions and linear inequalities. Linear functions and inequalities. Okay, guys, do your best, practice, develop some mastery, practice a lot, and get ready for exam. And I'll see you in my next lesson. This is Mr. Ainsworth. I'll see you then. Bye bye.